For inferences about means from two independent populations, the following box summarizes key elements of a hypothesis test and a confidence interval estimate of the difference between population means. Inference about two means independent samples. Objective. 1. Hypothesis test. Conduct a hypothesis test of a claim about two independent population means. Number 2. Confidence interval. Construct a confidence interval estimate of the difference between two independent population means. So the notation for two means. For population 1 and for population 2. So mu1 is going to represent the population mean 1. Mu2 is going to represent population mean 2. Sigma 1 represents population standard deviation 1. Sigma subscript 2 represents population standard deviation 2. N1 represents the size of the first sample 1. N2 represents the size of the second sample. X bar 1 is the sample mean for the first one. And sample mean 2 is the sample mean for the second one. S subscript 1 represents a sample standard deviation for 1. S subscript 2 represents a sample standard deviation for 2. Requirements. The values of standard deviation, the population standard deviation of population 1 and the population standard deviation of 2 are unknown, and we do not assume that they are equal. Number 2, the two samples are independent. Number 3, both samples are simple random samples. Number 4, either or both of these conditions are satisfied. The two sample sizes are both large, with sample size 1 is greater than 30 and sample size 2 being greater than 30, or both samples come from populations having normal distributions. And then for the first step, we want to be able to state the claim and the opposite of the claim. Number 2, we want to identify the null and the alternative hypothesis. Where the null hypothesis, the statement is assumed true until evidence indicates otherwise. The alternative hypothesis is the claim to be tested. And there's 3 ways to structure a hypothesis test. So for two-tailed, left-tailed, and right-tailed, the null hypothesis is always going to have the equality. So population mean 1 is going to equal population mean 2 for all 3 null hypotheses. For the alternative for the two-tailed, mu1 or population 1 is going to be not equal to population mean 2. For the left-tailed, the null hypothesis is that the population mean 1 is less than population mean 2. And for the right-tailed, for the alternative hypothesis, population mean 1 is greater than population mean 2. Now the alternative hypothesis is the one not containing equality. So the alternative hypothesis uses the symbol less than or greater than or not equal to. The null hypothesis is a symbolic expression that the parameter equals the fixed value being considered. For step 3, we want to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Number 4, we want to select the significance level alpha. Based on the seriousness of a type 1 error, we make alpha small if the consequences of rejecting a true null hypothesis are severe. The values of 0.05 and 0.01 are very common. Number 5, the test statistic for two means, independent samples with a null hypothesis where the population mean 1 is equal to population mean 2. So here's the formula for the test statistic. We have sample mean 1 minus sample mean 2 minus the quantity of population mean 1 minus population mean 2. Now, when we take a look at this, the population mean 1, if you take a look at the null hypothesis, population mean 1 is equal to population mean 2. Now, if we wanted to set this equal to 0, we would subtract population mean 2 to the left side. So population mean 1 minus population mean 2 is then going to equal 0. Therefore, this is going to equal 0 when we're solving our test statistic. And then we're going to divide that by the square root of the sample standard deviation 1 squared over population of the sample 1 plus the sample standard deviation 2 squared over the sample size of population 2. Now, again, you can see here where the population mean of 1 minus the population mean of 2 is equal to 0 is often assumed to be 0. Now, the degrees of freedom. Okay, we use this sample and conservative estimate. The degrees of freedom is going to equal the smaller of sample size 1 minus 1 and sample size 2 minus 1. And then technologies typically use the more accurate but more difficult estimate given by the following formula. So the degrees of freedom is going to be the following. Before we look at this formula, A is going to equal the sample standard deviation of 1 squared over N1, and S squared, that's going to be equal to B. So therefore, this would be equal to B, and B is going to equal the sample standard deviation of 2 squared over N2. The degrees of freedom would then equal A plus B squared over A squared minus N1 minus 1 plus B squared over N2 minus 1. Now we will be using the first simple and conservative estimate. So technology is automatically going to solve it this way. So when you're using technology, it might give you a different number than when you're using the simple and conservative estimate. Number 7, we're going to find the corresponding p-value or critical value, and you draw your curve and label. So for the p-value method, p-values are provided by technology or using the t-distribution, which is table A3, and critical values are provided by technology or using the t-distribution, again, table A3. Now, when making a decision using the p-value method, we reject the null if the p-value is less than or equal to the significance level, and we fail to reject the null if the p-value is greater than the significance level. For the critical value method, we reject the null hypothesis if the test statistic is in the critical region, and we fail to reject the null if the test statistic is not in the critical region. And then you're going to state the conclusion. So if the original claim does not include equality, then you reject the null hypothesis and you would state that there is sufficient evidence to support the claim that, followed by the original claim. If the original claim does not include equality and you fail to reject the null hypothesis, then you would state that there is not sufficient evidence to support the claim that, followed by the original claim. If the original claim includes equality and you reject the null hypothesis, then you would state that there is sufficient evidence to warrant rejection the claim that, followed by the original claim. And then if the original claim includes equality and you fail to reject the null hypothesis, then you would state that there is not sufficient evidence to warrant rejection the claim that, followed by the original claim. Now, when dealing with confidence interval estimates of the population mean minus the population mean 1 minus population mean 2 with the independent samples. So we would take sample mean 1 minus sample mean 2 as a quantity and then subtract the margin of error. That's the lower limit. On the right side, you would have, again, sample mean 1 minus sample mean 2 as a quantity and then adding the margin of error, and that would be the upper limit. And then the margin of error would equal the following. The critical t-value times the square root of the sample standard deviation squared 1 over n1 plus sample standard deviation squared 2 over n2. And then we would use the degrees of freedom, and the ones that we would use is the smaller of the n1 minus 1 or n2 minus 1. Equivalent methods. Now the p-value method of hypothesis testing, the critical value method of hypothesis testing, and confidence intervals all use the same distribution and standard error. So they are all equivalent in the sense that they result in the same conclusions.